Hello guys, welcome to the Viral Coder. Today we are going to write a program in C++ to solve a Sudoku. Sudoku is a grid of 9 into 9 cells. Each cell has to be filled out with the numbers between 1 to 9 without repeating any numbers within the row, column or 3 into 3 subgrid. You see, the cells which is filled with 0 is the blank cells in which we have to put the numbers in a such way that the numbers will not repeat in this row, in this column and in that 3 into 3 subgrid. Suppose we take this first row and second column example. So we cannot put 2 here because 2 is available in this row. We can put 1 here because 1 is not available in this row, 1 is not available in this column and 1 is not available in this 3 into 3 subgrid. We cannot put 3 here because 3 is available in this row, also in the column and also in the subgrid. We cannot put 4 here because 4 is available in this subgrid. So in a such way we have to fill fill the numbers in each of the blank cells. It is said that a good Sudoku has only one solution, right? To solve this problem, we will use an algorithm known as backtracking. Backtracking is an algorithm of computer science. You can understand this algorithm by a simple example, right? Suppose you are at point A and you have to reach to point B, and there are various paths exist between A to B, and some of the paths leads towards point B and some of path doesn't leads towards point B. You don't know which path leads towards point B. So you take one path, you go there and you find out that this path doesn't leads to point B. So you return back to the starting point, which means A, and you after that you eliminate this path from your set of solutions, right? You take another path, same happens, it doesn't lead to point B, you return back to your starting point. So this is known as backtracking. And you take another path and it leads to point B. Either you can stop there or you can return back and find the another solutions for that. So this algorithm is known as backtracking, and we will use this algorithm. We will implement backtracking by the concept of recursion. I assume that you have already known about the concept of recursion. When a function calls itself, then it is known as recursion. So let us move towards coding section. First of all, I will include IOStream. Then I will use the namespace. The first thing I am going to do is to store the whole Sudoku in a matrix of 9 into 9, right? So I will create a matrix, int grid, two-dimension array of 9 into 9, 9 rows and 9 columns, right? And I have copied the values of this Sudoku in a file so that it won't take so much time to type, right? So I will copy it from here and I will paste it. So this is our Sudoku, right? In a two-dimensional array, we have represented that Sudoku in a two-dimensional array. 0 is the blank spaces, blank cell in which we have to put the values, right? Let us write a program to print this, to print it in a good order. So I will write a program known as print Sudoku. I will write a function to print it. So it is a two-dimensional array, so there will be a nesting of loop for int I equal to 0, I is less than 9, I plus plus, then again for int j equal to 0, j is less than 9 and j plus plus, and then I will print the values slash t for a tab line, and the value of the name of array is grid, right? So I will type here grid, and the index will be I and j. After printing one row, I will break the line, and after printing the whole Sudoku, I will break another line, right? Let us save this program as sudoku.cpp, and let us check whether it is printing fine or not. So I will declare a main function, and I will print out that Sudoku. Cout the given Sudoku. Line break, and then I will call this function known as print Sudoku. Okay, print Sudoku. Fine. Compile this and run this. Oh, wait, there is some mistake, I think. Okay, the value of j, here the condition, right? J should be less than 9. Okay, fine. Let us compile again and let us run again. Fine. So this is our Sudoku, right? This is our given Sudoku, and we have printed it successfully. Okay. Now the next step is I will write a function to check whether a given number is valid on that position or not. Suppose if we have to check a number whether 1 is valid in this situation or not, 2 is valid in this situation or not. So I will write a function for that, right? So how will I implement this? The numbers which we are going to put here should not repeat in this row, in this column, and in this subgrid. Okay, so I will write a function and it will return true or false. So bool is valid, and it will receive 3 values, right? It first row in the position of that cell, right? So row and column, and the number which you want to put there, whether it is valid or not. So I will declare a variable for loop, for maintaining the loop. So let us check for c equal to 0. C is less than 9 and C plus plus, and if grid row and column. So the value of C will be changing in each loop. So we are checking in that entire row whether the number, if the number is available in that entire row, we will return false because that number cannot be put on that cell. So if it is equal to num, then we have to return false. Okay, again, now for r equal to 0, r is less than 9 and r plus plus, and if grid, here I will put r and I will fix the column, okay, equal to none. So here I am checking the entire row, the entire column, sorry, I am checking entire column whether that number is available in that column or not. Okay, so if the number is available in that column, which means we have to return false, which means we cannot put that number on that cell, and then we have to check the subgrid, right? So how will we know the position of subgrid? For that, we have row, so we will use this formula to find out the position of subgrid, the starting position of subgrid. Suppose we are checking this cell, we are finding whether the number can be put on this cell. So what is the position of subgrid? Subgrid starts from here, first row, 0th row and 0th column, right? So we have to find out the starting of subgrid, and then we will move 2 times forward, 2 times forward and column wise, and 2 times forward row wise, right? So row equal to row minus row mod 3, okay, and column equal to column minus column mod 3, fine. And then for int I equal to row, I is less than row plus 3, because it is a 3 into 3 subgrid, right? I plus plus, another loop for int j equal to colon, j is less than colon plus 3 and j plus plus, right? And if grid I and j equal to num, then again we will return false, which means that number which we are going to put there is available in that subgrid. So we have to return false. And if all this loop has been executed successfully and the function hasn't returned any value, which means that number can be put on that cell. So at last of the function we will return true, which means the number is not available in that row, in that column, and in that subgrid. Okay, so this is our is valid function, which will check whether that number is safe on that cell, whether the number which we are putting on that cell is valid or not. Now I will write a solver function. Okay, write solver. The first step is to check where are the empty cells, to find out where are the empty cells, right? So I will start a loop starting from index 0, I is less than 9, I plus plus, and then again for int j equal to 0, j is less than 9 and j plus plus, right? So let us first find out where the empty cell is. So the empty cell contains a value known as 0, okay? So if that grid, that cell of grid contains 0 is equal to 0, which means it is empty cell, right? So now I have to try all the possible values one by one, whether it leads to the solution or not. So let us say we can put 1 here because 1 is not available in this row, in this column, in this subgrid. We cannot put 2 here, we cannot put 3 here, we cannot put 4 here. We can put 5 here because 5 is not available in that row, in that column, and in that subgrid, right? We cannot put 6, cannot put 7, we can put 8. So 1, 5 and 8, we cannot put 9, right? So 1, 5 and 8 are the possible values of this cell. So we will try one by one. First we will try 1 and we will remove the problem size by 1. So if we put here 1 and we will check whether this solution, whether this value leads to a possible solution or not. So if it doesn't leads to a possible solution, then we will return back to the initial position, which is 0, and then we will put another value. What is another value? 5. Then again we will check, then again. So that is how it will work. That is how backtracking works, right? So the possible values can be between 1 to 9, and we will start that values int n equal to 1, right? N is less than 10, which means up to 9, n plus plus, and we will check whether this value of n is valid or not. Is valid. What is the row? Row is I. What is column? Column is j. And what is the possible value we are checking? We are putting n, which means the value of n is 1. So if it is valid, suppose if it is valid, then what we will do? We will put that value here. Grid I and j equal to n. We will put that value here, right? So we have put the value of n into that position. So let us say in that position we have put 1 for the first case, right? Then what we will do, that we will call this solver function again. Okay, we will call this solver function again. So this is recursion, and this is how we implement backtracking. So we have completely used the concept of recursion. So now what happens is that the problem size has been reduced by 1. So we have one less empty space now. So it will go here. Next time it will find the empty space, because here we have filled the value of n. Next time it will find the empty space here, right? So the same process will be repeated. So if we have reached to a solution, which means this for loop has entirely executed, and if there is no any empty space, left, it means that we have reached to a solution, right? So when we have reached to a solution, we will just print that matrix. We will just print that Sudoku. So how we know we have reached to the solution? If there is no any empty spaces left, which means the entire for loop has been executed, which means we have scanned starting from here to each row, each cell one by one to here, okay, and we haven't find any empty cell, which means we have reached to the solution. So we will print the Sudoku here, right? And suppose uh, this is the case where we have reached to the solution. Suppose we haven't reached to the solution, right? So what we do, we return back to the initial position. We return back to the starting point. So what will be the starting point? Grid ij, and we will put the value 0 here, because this is the starting point. This was the starting point. We have started with the value 0 here. Okay. So this is the case where we haven't reached to the solution, right? For some values we haven't reached to the solution. So for example, here three possible values can be put here: 1, 5 and 8. So suppose 1 doesn't lead to the solution, then we will try another value, right? 5. So we will traverse back to the initial point. First it will become 0 again, and then again we will try another value. This is backtracking, right? So this is where we are returning to the initial position, a starting point. And if we have tried all the values, right, from 1 to 9, how we will know that it is not, we have to reverse back, we have to go to starting point. We have tried all the values from 1 to 9 and none of the value is valid on that position, which means the previous values has been put wrong in a wrong order. So if we have tried all the possible values from 1 to 9 and still we are not getting the solution, so we will return back. So we will return from here, right? And if we will return, then it means the initial, we will reach to the initial value of the grid, which will be ij. The index of ij will be again put to the 0, which means we have returned to the initial value, we have returned to the initial point. So this is how the solver works. This is how the backtracking works. So we have successfully wrote the algorithm of solver. So now what we have to do is we have to call this solver function into the main. So let us print one line here, cout the solution. Okay, and indel, and we will call that solver function here. Right, okay, let us save this, let us compile this, and let us execute this. So here is our solver, and as you can see, we have successfully solved that Sudoku, right, using the backtracking algorithm. Thank you very much.